Mario, once again, today is Thursday, August 28, 2025. In continuation with this project, rebuilding this Delta 4-inch, 6-inch disc sander. I have two of these machines. I just completed the reassembly of this machine after taking out the startup winding from the motor that was burnt, and I'm just running this motor just on the main winding with a little help by giving it a little push here, just a manual start. Motor's right now connected directly to this switch, which is in line with AC cord, the AC line. I'm waiting for a circuit breaker that I'm going to be installing in line with this switch, just for added safety. But basically, when you turn this on, you hear the humming, and all you have to do is just give it a little push on the belt, on that on the belt track, and it gets the motor going. So this machine is back in working order. You just got to finish the rest of the assembly of the rest of the parts, and it's going to go on my shop. It's something that I have been kind of missing, these nice machines. They're not that small, and they're not that that big. They're perfect for the stuff that I have been doing here for many years. For model work and some things around the house. I did find that this device here is actually a starting relay, very similar to the ones that are employed in refrigerators, for the compressors, to get the compressor going. And this has to be mounted in, with the in a certain way, so that the shaft that has the contactor plate is disconnected just by gravity. So when it's mounted this way, like that, inside this box right here, this relay is not it has no contact connection whatsoever between these 2 points right here. Once that gets going and electricity flows to this, the contactor makes contact, energizes the starting coil, the one that I burned inside the motor, and once that gets up to a certain speed, this disconnects. But if this locks in the on position or the on state, it's going to that startup coil is going to heat up beyond a certain point, and it's going to burn. And so that's what I believe happened. It's just analyzing the workings of these parts right here and components. But so I'm just to keep it really simple, the only way to get single phase without the starting coil going is by manually inducing a phase shift. So just to get the electromagnetic fields, just at the right position to get this motor going. But once it picks up speed, as you saw me do that, the motor runs just fine. Otherwise, I mean, I guess I don't know, without a starting coil, how you would start a motor even electronically, because you do need you need to be in the electromagnetic field with some device, to establish a phase shift, so that the motor gets started. Without having that inside the motor, I don't know how else you would do that other than manually starting it, like I said, manually and mechanically getting this to spin. If anybody out there that's seeing this video knows of another way to do this without the starting coil, let me know. I I could have rewound the starting coil inside the motor. It was an option that I was contemplating on doing, but after looking at it's quite a lot of work, doing all that winding there. 24 turns, per winding, and I believe there were, according to my old diagram, I believe, let's see, I marked 24 turns, and there are various lengths because these coils kind of stagger one on top of the other one. You have a coil between the two of those slots, and then you have the other one that goes on top of that, and then on top of that one, and then on top of that other one. So that's where these lengths come in. I have marked here 13, 11, 9.5, and 7.5, and then mirror image that on the other side, north and south side of the windings, because you got to have a north and a south pole winding on the startup coil. It's similar to the main winding. Two-pole. I believe this is called a two-pole motor, a single phase. So anyway, this is working, and it's working great. I'm kind of happy that I was finally able to at least get one going here. So this is going to go back in my shop, and I'll be using this. Hopefully, it'll last me another few years. Nice machines. If you have a similar machine, you can do the same thing I did here. Just watch my videos where I show what I did and how I remove the winding. Just got to be careful when you do that, so not to disturb the main winding. And hopefully your main winding is okay. Mine was reading between 4.2 ohms. The main winding between the 4.2 and 5 point somewhere around 5.2. So the winding, that's how I was able to tell that the winding was just fine. You want to do that measurement before you connect that to the AC line, because if you have a short in that winding, you're gonna create a spark or a fire. So just be careful when you work with those things. Make sure that you understand what you're doing, and if not, ask or watch some videos. There are a lot of videos on people working on motors. Not necessarily what I did here with this particular Delta 4-inch belt sander, because I have not come across anybody doing this. What I show in my videos with respect to this particular belt sander, even replacing the motor with something similar. I had a hard time finding videos of people doing that. I went on YouTube. I went online, see if there are other areas that may be talking about belt sanders and people retrofitting or replacing motors with maybe something similar. I just could not find a similar motor to retrofit this machine with. And I did find one, the same motor, a used motor, and that was going to be more than buying just a new sander. I don't want to buy a new sander. I wanted to use these because I really like the machines, like I said, and so this was my only option. It works. Mario, once again, thanks for watching. Stay tuned for more.